Good morning to all you incredibly diligent students. My name is Joab Rockman, and here's another short video on how to perform chemical engineering calculations using a not-so-simple calculator. Today we're going to use the calculator's powerful internal solve function to quickly solve a single variable equation. We'll use a previous example I talked about for two expressions solved in series using successive substitution, where we added heat to ammonia to calculate the final temperature. Quickly recapping the theory behind this, for a constant pressure, zero phase change, zero reaction process, the duty is given as Q equals N delta H equals N times R times the expression in the brackets times T minus T0. Now let's recall the problem statement. What is the final temperature T when heat in the amount of 36,000 kilojoule is added to 1 kilomole of ammonia, initially at 530 Kelvin, in a steady flow process at 1 bar? For NH3, A equals 3.578, B equals 3.020 times 10 minus 3, C equals 0, and D equals minus 0.0186 times 10 to the 5. So for our example, we're solving the following equation. Recall C equals 0 and N equals 1 in this example. 36,000 equals 8.314 times brackets A plus B over 2 T plus 530, close brackets, plus D over 530T, close the big brackets, all this times T minus 530. Let's define the constants. 3.578 will set into A. 3.020 times 10 minus 3 will set into B. Minus 0.0186 times 10 to the 5 set into D. Now type in the equation as written above using the A, B, and D constants, and instead of T we'll enter the variable X, which may be found in the upper right corner on newer models, or as a combination of the alpha and left parenthesis buttons. We'll then type in the equal sign, alpha calc combination, so the expression will look like 36,000 equals 8.314 times brackets A plus B over 2 times X plus 530 plus D over 530X, close brackets, times X minus 530. Note that all the letters or expressions in red were produced using the alpha button. The nice thing about using the solve function is that it doesn't matter how I arrange the equation. As long as I have the equals sign between two expressions, the calculator will use Newton's method to solve and obtain an equality between the two sides. Pressing the solve button, the shift calc combo, will start the solver, and the calculator gives a list of the constant values as well as an initial value for x. Older models will ask for an initial value of x. Newer ones will give a menu of all the variables that appear in the equation, in this case a, b, d, and x, and their current values. Choose the variable x, assign it an initial value of 530 Kelvin, which is equal to T0. Then re-choose it again and press the equals button to initiate the solver algorithm. The solver uses Newton's method, and the answer quickly converges to 1225.4867 Kelvin. The results are displayed in a summary screen that show the expression solved, the final value of the variable solved, and the difference between the values on the left and right sides of the equation, which represents the error of the numerical solution. You may use the left and right cursor buttons to edit the equation and rerun the solver, so if you made a mistake or want to modify the equation, it's easy to do so. Now some cautionary words regarding the Casio calculator's ability to understand mathematical expressions. Note how I've used the fraction format in writing out the equation. For example, writing b over 2 times x plus 530 would be misinterpreted by the calculator as b over brackets 2 times x plus 530, putting the x plus 530 in the denominator, which is not what we meant. A better way to enter this expression would be to either enter a multiplication operand following the b over 2 expression, or use the fraction button, or use parenthesis. I hope you enjoyed this video of how to use the calculator's solver function. This is Yoav Rockman saying to all you diligent students, keep up the